All right, let's get started. Hello, everybody, and welcome to Lecture 4, where we will talk about supply and demand, but from the perspective of what this says for environmental economics. And so essentially what we're trying to do is embed the tools of supply and demand within the planetary donut framework. And so I just have a piece of art here that I made by hand. The agenda for today, specifically, we're going to pick up where we left off, which was going through the principles of consumer choice, and how they use indifference curves and their budget constraint to come up with their utility maximizing choice. We're going to transition from that into how do we represent the whole market and all of the choices of individuals making that utility maximizing choice, and how can this be expressed as a demand curve? Then we'll switch over to building the market supply curve. This is much simpler than it is for the individual. Individuals, you need to think about indifference curves and budgets and all sorts of things. For the supplier, it's a whole lot easier. Their marginal cost is the demand curve that the individual firm faces, and so we just sort of have it from the data. Either way, once we have those two things in place, we'll talk about supply and demand in equilibrium and transition to how this all relates to environmental economics. And so I have another handmade image here of the supply curve for donuts, keeping with our theme. Um, Actually, I did want to ask the class, I love AI. Does anybody else here love AI? Yeah. Does anybody hate AI? Yeah. It's becoming a divisive thing. So I hope this doesn't trigger anybody here, but I don't know. It's just like make an image that describes this slide, and it's kind of cool. Actually research AI and on a large NSF National Science Foundation grant for researching how AI can benefit the environment, basically. And so I don't only like it from the perspective of making ridiculous images really fast, but nonetheless, I do enjoy that. Anyways, no, I only ask because I'm hearing of more and more people who like are really offended by AI use, like especially where it replaces artists or where it replaces computer programmers. I know a lot of my friends have kids who are like about 17 or so and thinking about what career path do they want to go down. And, the idea of being a computer programmer, it's a lot more questionable now when we have AI that can code up a lot of things. I still would strongly endorse it because it's a way of thinking, not just a way of typing. But nonetheless, I think we're seeing an emergence of split opinions on AI. Anyways, so let's dive right into the content. Thinking about how do we go from those individual utility maximizing choices up to the full market demand curve. And just to remind ourselves where we are, yester lecture, we showed how the consumer chooses what to consume. And the punchline is the optimal set of good X here and good Y here is going to be the one that corresponds to this point, right? Where the indifference curve is just tangent to the budget curve. Where we can go from this is that we can do a lot more with this by playing around with the different inputs into this. And so this is where, you can go onto our class website, and I think I've updated most of the links and added some new ones. But there's a bunch of interactive visualizations. I won't click over to it now because I've just sort of copied and pasted some of the key things. But these two different graphs here, all I did was drag the slider for what is the price of good X. And so here, this is one we've seen before. When the price of good X is 2, that tangency point happens to be where quantity of good X is 25. So that's just the result of maximizing utility subject to their budget constraint. But what we can do is basically drag that slider, fiddle around with it. Here, this is just when I dragged the slider to the price of good X equals 5. And then the animation just jumps here immediately, but the new tangency point is now here, and this corresponds to Q equals 10. And so essentially for any price for X, you can just observe what happens to the utility maximizing quantity that we get from that price. And so, yeah, we can see that. But the kind of cool thing is we can create a whole new graph that describes all of the relationship, all of the possibilities between different prices of X and number of quantity that utility maximizing agent would do. And so what does that look like? Um, Here is uh, a, a static screenshot of this question where I'm actually going to go interactive for this one. So let me pull that up. So just to remind you, in games. Oh wait, no, I didn't. I didn't post it yet. There at least. So here it's in supply and demand. I haven't put it under the games category yet. But you can see these interactive versions. And so what I was saying before is as we drag the price around um, and solve the utility maximization problem, meaning, oh, sorry, somebody always needs to shout at me quicker rather than later that I think something is shared, but it's not. Whoa. Okay, and so this is what I was just talking about, is here we have the optimal choice for this agent. But what happens when we drag the price bar around? We can, all it's doing here is re-solving for a new budget constraint. And so when the price of X goes up, we learned in our principles class, the budget constraint, the budget curve here will rotate inwards because you can't buy as much of good X. But we're adding a special ingredient to it. Now we solve for the optimal number of X's to buy, and then we plot that over here. And so all we're doing here is extracting from this figure for each different price that we tried out from dragging this bar around, what is the X that was actually demanded by that consumer? And so you can do this mathematically, but I think it's really easy to see. Let's just try it out, and we then plot all those different utility maximizing combinations, and we get this curve. And what is this? This is the individual's demand curve. In principles, it's really hard to make this point because it relies on a little bit extra concepts like indifference curves and such. We just kind of go from the logic of individuals have demand curves. But what I'm trying to show here is at a fundamental level, it derives straight from the mathematics of maximizing utility subject to a budget constraint. And the demand curve is just describing what happens given that optimization when you drag the price around. And that is literally and exactly what we mean when we say the individual demand curve. Okay, so from there, oops, there's one very small point is that there's another one. This one I won't go interactive on, but it's there on the website if you'd like it. Is we've so far been talking about how just one individual's utility maximization problem can lead to their demand curve. But what happens if you want to solve supply and demand? You actually need the whole market. But this still can also be directly connected back to consumer theory. And here it illustrates it as we have two different people and their budget and indifference curves. They're different people, right? So they have different incomes. That's represented by, I guess, Bob is a lot richer. He can afford a lot more things. And they also have slightly different preferences. But the biggest difference is that when Alice optimizes, she only gets this amount, like 16 units of X, and Bob gets much more at, it's a little hard for me to see, 26. The way we go from that information about individuals, or eventually all individuals in society, is we just do what's called horizontal summation. You might remember that. Here it's just saying, let's add the quantity from Alice to the quantity that Bob demands at each of the different prices. So at this price, here is Alice, here is Bob. The market is just summing those two. And so basically how far it is from the y-axis to Alice. We just sort of tack that on here at the end of Bob's, and that's there. And the interactive version that generated this is the same idea, is if you dragged the price bar around and just watched what different quantities of X the individual would want to buy, that's what will also chart out then the market demand curve. So I think this is kind of, it's elegant. I really like it. It comes down to basic preferences. Like if you can argue that we can have a utility function that expresses those preferences, like I prefer A to B, B to C, and that there's this utility function that also can put a number on that, the rest of this is all unambiguous. And it's very clean theory. And this is kind of why some people like to think about economics as almost like a physics. It's very clean theory. If you accept the basic premise about can you express it with a utility function, the rest of it is very consistent. Okay. That's just what we did for consumers, but to fill out the supply and demand relationship, we also obviously need suppliers, and that is much more simple because there isn't this complex question of what is utility. The idea of what is utility, I have a hard time wrapping my head around that. But if you ask me the question for the producer, what is profit? I have a really easy time understanding what profit is. It's total revenue minus total cost. There's no philosophy here. And so it's a lot easier to define the supply curve. But basically, this is our Econ 101 is, we typically just look at it from a data perspective is if we observe that when the price is 6 for a cup of coffee, this is how much coffee is demanded per month. And you essentially take a data table like this that describes all of the quantity demanded for all the prices and plot it. So this is literally my Econ 1101 graph. But I want to go one step deeper on this because this is a 3000 level class and talk about what's underneath that. Typically, when you do Econ 101, you talk about the supply curve at the very beginning of class, and then eventually later on, you talk about profit maximization and average fixed cost and average total cost and marginal cost and all that stuff. But they're actually also tightly related. I think the best way to think about it, though, is that the producer and their decision is described by a production function. And this is really parallel to how the consumer's decision is described by their utility function. This is what we're going to use here. The production function is going to be some function f that when we compute it gives us the quantity produced, right? And here we're going to write it in general form first of just saying what are the inputs to this function. And the basic ones that are usually included are labor and capital. Now, if you were in a non-environmental econ class, you would draw the closing parenthesis right there. And this is the real first time we see the blind spot of economics, is that standard econ basically summarizes it down to only this, and that there is nothing else that goes into the production function. But because we're an environmental econ class, this is just the first of many modifications we're going to have to the basic theory. But we're also going to have this other input, N. And so, oops, I guess I never defined those. Oh, yes, I did. Other than to say that natural resources, we'll call that the N in this equation. And that could be things like land or raw minerals that you get up from the ground or timber that you cut down from forests. And this just means that we're going to be really explicit, not just about labor and capital, but also the depletable stocks of inputs that we have. And this is so often and fundamentally ignored by economists that now we're starting to see, I think, the actual sophisticated argument about why economics has gone down some pretty unsustainable paths, is they assume it's infinite or doesn't exist or doesn't matter. Okay. So that's the production function. And from that, we're going to be able to get our supply function. But first, we got to talk about a little bit about the law of diminishing returns. And so if you want to increase production, this production function at least says that you got to increase these inputs. So you want to produce more, plug in more labor or more capital or more natural resources, or probably more of all of them. And you will get more product that comes out of it. And so that's what this graph here is going to describe is as you have some sort of input factor, and in this case that I have on the screen, it's going to focus on labor, but it really could be any of them, but let's just call it labor for now. You're going to have, for all the different levels of L you might put into that, we're going to want to observe what is the total amount produced, basically that Q. And so we'll give it a special term here, total product. And there's going to be some relationship. And the sort of key insight, and this is related to that fundamental law that we've talked about, the law of diminishing returns. There's like a special version of that for the producer. It's the law of diminishing total productivity. Essentially the same thing, but it says that at some point, as you increase your input factors, it's going to start increasing your total product at a decreasing rate. So right about here is the point where it switches from more input is increasing our product at an accelerating rate to here, it now increasing our inputs still increases our product, but at a decreasing rate. And so this is kind of like the startup zone, and this is where coordination among people causes it to be more effective. Like there's a lot of cases where two people doing a task are way more than twice as good at it than one person, right? And the easy example is two people using a two-handed saw to cut down a tree. They're not twice as fast as a single person with that same saw. They're probably like 100 times faster because you need two people on the saw. That's this zone. Most production decisions, though, quickly accelerate out of this zone. And so this is where almost all the actual real economics happens, where increasing the inputs does help, but at an ever decreasing rate. Though it's worth noting that there's this last zone of where there's straight up reductions in the total product. And so the example there is if you had like the total product graph for a restaurant and your variable input was cooks and your total product was meals, stage one, you'd have a coordination causing it to go up at an increasing rate where we specialize. I do the cutting and you do the stirring and frying or whatever. Stage two is where it's increasing at a decreasing rate. So now we got a bunch of cooks in the kitchen and we specialize still, but now we're kind of bumping elbows. And we could describe this as congestion. And this is because the kitchen is a fixed input. It's only so big. And that's that increasing at a decreasing rate zone. But then stage three, and this is where like the image in your head gets kind of funny. Oh, I should have used ChatGPT to make an image of this one. Is you get to a point where adding more cooks into the kitchen actually decreases your total product. And so if you think of a small little restaurant, that has that can serve 25 people at a time, what would be the productivity of their kitchen if they had 1,000 cooks? Zero. You can't even fit that many people in a kitchen. And so this part, frankly, not very interesting, maybe a little funny, but most of the decisions are always going to happen in this part here. Okay, so that was Econ 101. And in Econ 101, you're given the sort of take it on faith that this somehow can be expressed as a supply function, but typically you don't learn how exactly do you go from the firm's profit maximizing decision to the supply function. We just tell you what it is. But the answer here is I've made a tool for this one too. I won't go interactive on this, but you can find it on the website. Is here, we're going to do the same thing as before that we did for the consumer, where we dragged the price around and just watched what their choice was for how much Q to buy. Now we're going to do the same thing. We're going to drag the market price around and see what happens to the profit maximizing quantity the producer produces. And so hopefully these look really familiar from your Econ 101 classes. We spent a lot of time on this. Price is the marginal revenue. Here's your marginal cost curve. The profit maximizing one is always setting price equals to marginal cost. And I know I'm going fast, but I'm presuming everybody has studied this very well. And the other things here are like, that's the profit box. And so this is the point that makes that profit box the largest. Um, but what we can do is when we drag around that, we can just observe what is the quantity they produce. We've already got it expressed in terms of the price and the quantity. So this is where it's different than the consumer problem where we had one good versus the other good. Here we already have it as price versus quantity. And so just simply dragging around the market price and adding together all of the different firms, you might have heterogeneous firms. That's how you can, that's how you can then trace out the supply curve. And so that's, I think, kind of cool. I just minimized the wrong thing. Where'd it go? Okay, I've totally confused myself. There we go. Oh, I know why it didn't work. Okay. So that's supply. So hey, we just did supply, which is normally 5 lectures or whatever, but we did it more comprehensively and in only about 10 minutes. So we're definitely past Econ 101. Why do we want to do this? Is because we want to use the power of equilibrium. If I had a theater voice, I would have said that with a much more resonating tone. I want to talk about equilibrium, how it derives from the combination of supply and demand, and why it's so powerful. The powerfulness of it essentially comes down to there's all sorts of forces in the economy that pushes the outcomes towards the equilibrium. And this is useful because you can make strong predictions about what is likely to happen. And, you know, the sort of punchline is that if you can define mathematically what the equilibrium price and quantity would be, if you're some analyst and you're wanting to make a prediction for how should your business operate under different future scenarios where we're worried the price is going to change, you simply assume the equilibrium is going to happen and make a strong prediction that that's the new price and quantity that will happen. And that's very useful business information if you want to make a lot of money. But basically, the definition of an equilibrium, whether it's in an economy or physics class or in a bowl, is it's a state of the system where the opposing forces are balanced. And so the classic example of an equilibrium would be this marble in this glass bowl. Is you could knock it out of there and you could, you know, give it a tap and it would ride up the wall of the glass bowl here. But there'd be some set of forces, in this case, gravity in the shape of the bowl, that causes it inexorably to go back to the equilibrium point. And so whatever is the lowest point of that bowl is the equilibrium. And the economy, as we're going to argue, is essentially the same way. You did this in Econ 101. So I'll go through it very fast. The punchline for supply and demand is that just like the bowl, there's an equilibrium point here. And just like gravity pulled it to the bottom of the bowl, two different forces, in this case, we'll call them excess supply and excess demand, are going to push the decisions of the producer and the consumer right to this point. So what does that look like? First off, if anybody says solve the equilibrium, that's really easy. Just find the point. You don't even have to think about this. Just as long as you remember equilibrium is where supply equals demand, the rest of the logic holds. But I still want to talk through why that statement is something that you can simply memorize. And the answer is that any other point besides P star, we're going to have something go wrong. And so if the price for some good goes way up, what's going to happen to our two different agents in this system? The consumer is represented by the demand curve. Well, something just got really expensive. I'm going to buy less of it. If video games now cost $159 per game, I would buy fewer. That's basic demand. And so I would want to produce here. But if for some reason video game companies thought that they could sell their computer games for $159, probably a whole bunch of new firms would enter. Even existing firms would produce more, hire a bunch more workers to plug into their existing production function. And they would really love it if they could produce this really high level of video games. But the problem is these don't match. The quantity demanded will be way below the quantity supplied at this price. And what's going to happen is producers will have an incentive to lower prices. Here it's really easy. If you think about what happens when a store buys too much of a good, it's filling up their back room, like their warehouse is literally overflowing with toilet paper or something. What are they going to do? They're going to have a sale, try to get rid of it as quick as possible. Because it's literally a cost for them. They're running out of storage space, but also it's just a real hassle. And so they'll do discounts. They'll lower the price, some version of, hey, we got to get rid of all this extra stuff that's taking up space. And so they will essentially lower price. And that will cause a downward pressure. And so suppose it goes a little bit down, two things will happen is consumers won't want to buy as much of that thing because it's now will want to buy more of that thing because it's a little bit less expensive. And some of those producers may not want to produce anymore at that lower level. But we still, with this intermediate step, would have more excess supply, so the discounts would continue all the way down until there is no excess supply. And so that's what happens when the price goes above the equilibrium price. We get surplus. Going faster, the same thing, but in reverse happens when we have a price that is below the equilibrium price. What do we have then is if now all of a sudden video games cost $1.99, I'm going to buy a lot more, even ones that I might not play very much. And if you look, I have a lot of games on my Steam account. It's what I use to buy games. And yeah, when it goes on sale, I buy a lot of games and I'm like, actually, I don't want to play that. So I don't know. I should know the stats on this. I probably like a third of my games have 0 hours of playtime, never even opened. Yeah, and that's because they have sales or for 99 cents. I'm like, man, maybe I will buy this. Anyways, the point is, I would have a higher level of demand at this really low price. But the problem is companies that produce things might not be profitable with that really low price. Video games is sort of a bad example because it's you're producing a digital thing which can be reproduced for free, but it's a lot easier to think about if thinking like fish. There's people that are really bad at fishing or don't have a good boat. They can't be as productive as those ones that have an awesome fishing boat. And so they will drop out of the market. But regardless, it's going to cause this wedge in between supply and demand where I want to buy a lot, but the producers only want to produce a little. And so what happens when you have consumers wanting to buy more than exists? Well, think of concert tickets. That's a classic example of something where, they sell out real quick if it's Taylor Swift or something. What happens? There's a secondary market, right? You can then resell your tickets, and they're trying to reduce this with Ticketmaster and different approaches because it feels unfair. But if those safeguards weren't in there, like people will buy it for $300 and sell it back immediately to somebody for $1,200. And so this is sort of the opposite of discounts. They're giving like a negative discount. They're willing to pay more. And they will find a way through black markets or reselling or whatever to be willing to increase more prices. But frankly, what will probably happen is the producers will see, hey, wait a minute, I could get away with a higher price. I get to sell it for more. And so that's probably the more direct way. But regardless, they will keep increasing the price when they think people will keep on buying it. And that will continue until the price equals, the quantity supplied equals the quantity demanded at our magical equilibrium point. So all I'm trying to say is that anywhere on this graph besides point E has these forces conspiring to push it towards E. And so that's why I drew it as a bowl like this. Okay. So that's the intro. But I want to solve this. The fun of economics is that it's not just graphs. The graphs are there unambiguously representing mathematical concepts, and we can then actually compute these things. And so I want to start to introduce the first of our mathematical approaches to this. So far, we haven't had you write much math down. That's technically math, but not too much. I want to now do it where we're going to have demand curves that are represented by basic line equations. I decided I'm going to skip this part. This is just a different representation of the fact that the market demand curve, this one, is a horizontal summation. And so here I've given you some extra notation is that consumer one had this demand curve, consumer two had this demand curve. We can add them together and get this demand curve, at least from here on below. You can ignore that from now, but we're going to focus on this exact expression. So let's get started with that. So the demand curve, when we compute it, it's going to get us the quantity demanded. That's the output of it. The sort of generalized expression for it, before we give it a specific form, we'll just call it the demand function, is going to be an input of prices. And what we're going to add now with that part underneath the market line is a specific version of this general form. And that will be something that you could plug into a calculator. And I got to remember my exact ones. Okay, so those are just the three different ways of expressing the same thing, but that's what we're going to use. One important note, this is what's referred to as, oh, did I go too high for you all back there? Can you see it? Okay. This is what's referred to as direct demand. Intro skips over this, but a direct demand curve is one where you look at the quantity demanded as the output of the function. So in other words, Q is on the left and P is the thing you plug into the function. That's called direct demand. That's necessary for the horizontal summation because that's what we're summing over, is we want to sum the quantities this way. The other part of this is the direct supply curve. Just like with the consumer, here's another example of how we get market supply, is we have supply function for firm one and for firm two, and we're just going to aggregate them with that horizontal. But let's focus on this one. QS is going to be equal to 9/2, or 4.5, I'll probably write in a moment, times P. And so that's going to be just a basic upward sloping one. So before we had the downward sloping one because of this negative slope on price. Here we have a positive slope on price. It doesn't have an intercept, but I could have added that without loss. But who solved these before? This is like the canonical thing you do in intermediate, right? It's right before you solve the Lagrangian if you do. But I'm going to just walk through it again because we'll have these on problem sets. And the reason I'm doing this is because this will be the tool that we're going to use to understand some very important concepts like externalities, open access fisheries, and stuff like that. So let's just get a good reminder on how we solve this. And so the punchline that we just talked about before is set supply equals demand. It's our key insight. There's a lot of work to get to the statement about the excess supply and surplus and shortage, whatever, but let's just start here. That means we can just take these two things and set them equal to each other. And so let's do that. I'll just walk through the math on the board. It's on the slide too, obviously, but I just like to walk through it on the board so you can do it in your hand. I would recommend following along with a pencil or your screen or whatever, because the act of doing it will help you do better on the test. So we're just going to write the quantity demanded on the left-hand side. And here's the magic. I guess I should have done it the other way around. I'll switch it in a second. Supply equals demand, so we're going to know that it's going to equal 4.5 P. Oh, and I guess on the slides I did do it the other way around. That's a little bit more intuitive. But all we got to do now is solve for P by getting P by itself. And so how would we do that? First, let's get the coefficients by itself and the things that are multiplied by P together. So it would be, I'm going to actually switch this over to whatever. We'll do it the fun way. So 4.5 P minus 2.67 P. So you can calculate what that is, but it's just going to come out to, oops, sorry, I did it wrong. plus. This is a minus, so when it comes over here, it's plus. And so simplify it further, 28.67 equals 7.167 E. Now what do? Flip that over there, and I'm going to now put P on the left-hand side equals, I flipped it first, and then I'm going to put this under that. And that's a calculator one that I couldn't do. But when you compute that out, I've chosen the numbers very precisely, so it equals 4. And that's, we'll give that one a P star, because now we got what we want, the equilibrium price. The world is conspiring to make price equal to 4, and anything else in the world will feel out of whack. But once you have P star, it's easy to get Q star. You actually just plug 4 into either one of those, our supply or demand functions. And so this one's probably easiest. Q star equals 9 over 2, but now we're going to plug in 4. Because that's the P star, and that will equal 4.5 times 4 equals 18. Any questions on the algebra? I don't want to challenge you on the algebra. I'm hoping this is easy, but that's the point. I don't want to have the class be hard because the algebra is hard. I want the class to be hard because you're addressing hard challenges with powerful tools. Okay. But just tying all the pieces together, here's one graph that shows it all. P star is 4. Q star is 18. And so we know we did our algebra right when that combination of P and Q indeed goes to the point where supply equals demand. Okay. So that was the direct version of this problem. Often, however, actually more common, I would say, is we deal with the inverse supply and demand. And what's going on here is, for historical reasons, dumb reasons, economists always put price on the vertical axis of our plots, right? That's just how we draw it. I mean, there's no reason it has to be that way. You could put price on the horizontal axis and quantity on the vertical axis, but for historical reasons, we just keep doing it that way. Or in other words, we express it as quantity demanded is a function of price. The problem, it's very unintuitive to draw graphs that way, especially when you're doing them from the core mathematics. And the reason for this is usually when we have functions in mathematics, we're thinking of the horizontal axis, x, is what's plugged into the function, and y is the result of the function. So if we wanted to make our expression of supply and demand match that logic, we will use what are called inverse supply and demand functions. And that's basically saying, instead of the demand function taking P as an argument, we're going to flip them around. Indirect demand now would say that we're going to solve for P by plugging in different quantity demanded. And so it's sort of trivial. You know, you could take these equations that I have here on the board and just rearrange them. So, is it price on the outside or the inside? It's mathematically easy, but this is just a lot easier to plot. And so let's give some specific ones. So 15 minus Q divided by 2. So basically it's saying it has a slope of negative 0.5. So we have what we desire, our downward sloping demand curve. An inverse supply, it's an inverse one, so we're putting the Q in here instead of the P, just like here, equals 6 plus Q. So it's upward sloping at a slope of 1. Okay, so we're going to practice solving this one too. It's pretty darn similar to what we did. But the logic is just going to be the same. So set supply equals demand, and I'll put it in the right order this time. S equals D means we're going to have 15 minus Q over 2 equals 6 plus Q. And so our strategy is to isolate Q. So how do we do that? Let's first get these over onto one side. So 15 minus 6 is 9. And we're going to move this one over here. So q plus q over 2. All right, so then how do we do this one? That's probably the place where most people will get tripped up, is if you want to be able to add q to a q over 2, the problem is they have different divisors, right? And so what we really need to do, you can't do this directly. We need to have them have the same divisor of here. And so we're just going to put a 2 on both sides. It's the same thing, obviously, because this is 1. But now, I'll draw it down here. We have 2q plus 1q is 3q, and they have the same root. Okay. So our answer is 9 equals 3q over 2. I guess a few more steps to get it right. We can now get our q star. So we're going to multiply it by 2/3, which means we pull the 2/3 be next to the 9. And that's pretty easy to see as it's 6. So we have a q star of 6. And then we are just going to get the other thing we want by plugging it into, I guess I left this off, but I said it. We need to get the P by solving one of our supply demand equations, but using the Q star. So this one's real easy. So P star equals 6 plus Q star equals 12. And so graphically, it looks nice. We've got it. That looks like it's about 12. That's obviously 6. And so it all worked. Any questions on the mathematics of it? Okay, we'll have our, oh yeah. It depends on the question. Sometimes the fraction way makes more sense. Like here, I did it. It's probably easier to think about it in terms of a decimal because then you can just do 0.5 plus 1. I will not grade you up or down regardless of how you choose to do it. But sometimes one way is more error prone than the other. So maybe try both depending. Yeah.
Is there circumstance?
I've done that in past years. So maybe, well, the answer is I haven't made the tests yet. So I don't know. But now that that's on my mind, I think the answer just increased in likelihood. But yeah, just. Yep. So let's take this one. And so let's just drop that middle part. So this is indirect or inverse demand, sometimes called indirect demand. I think I pushed my words there. But to get the direct demand, we're just going to flip it so that so basically I just moved the 6 here over to here and then put the Q on the left hand side. Yep. And same with over there. You can do something similar. Yeah, good question. Any other questions? We went faster than expected, which is good. And so all I will say is in terms of where we're going from this, so you get a sense of the trajectory. So first off, as you see, I've been updating the website. It's being populated. And so here are the slides for today. Obviously not a video yet because I still have to do my awesome YouTube video editing skills, which is annoying. But the other things are filled in with video and such. And, you know, here I've got the utility maximization games. And so do play around with those if you want to. I think I corrected all the links that were done wrong the other day. So yeah. I haven't made the assignment yet, but in terms of assignments coming up, what I'm thinking is right after class here, I'm going to put this up. And that'll be just like the first one, a really quick response. Might take you less than 5 minutes, but just keep you engaged with it. That'll be due on Monday. But after it'll be due at the end of Monday. So technically you can do it after class on Monday. And then on Monday is when we'll also have our first problem set assigned. So far, there still haven't been any readings because I'm just creating the content. And so I guess the reading is technically the website. But we're going to start, once we start getting into things like cost benefit analysis, we're going to refer back to our actual textbook. And did everybody succeed at getting access to that? I just wanted to make sure that it was downloadable. Did anybody succeed at downloading it? Okay, it's a little dicey because you have to be logged in, but cool. All right, well, I know what I'm doing this afternoon. It's going to be interesting. Anybody else have fun plans? There's a lot going on in town today. Anyways, let's call it a bit early, and I will follow up on Canvas announcements with what next steps are coming. So thank you so much.